Okay, we are finishing up law of sines. So we're on the back here. On Friday, we did law of sines if we had angle, angle, side, or angle, side, angle. So I'm going, and we used those same terms when we were proving triangles congruent in geometry. Then we had 5 postulates and theorems. So I'm going to remind you why it worked in geometry, so I can kind of show you why this one, the side, side, angle one, is a little weirder. So if I have these triangles here, and we're going to pretend when I draw them that they're actually congruent, okay? Look, they're kind of close. And so if I have angle, angle, side, angle, angle, side, angle, angle, side. So what that postulator theorem says, if 2 angles and the non-included side of one triangle is congruent to 2 angles and the non-included side of another triangle, then the 2 triangles are congruent. That's because these things that are marked are basically locked down, like they are what they are. We have no idea what the other 2 sides or the other angle is, but because of the nature of a triangle, they can only be, there's only one possible thing they could be. That's why those 2 triangles are congruent. Does that make sense to you? And so the side-side angle doesn't work. We can't use that for congruence because it's what's called the ambiguous case. We could have more than one answer. So here, if I draw the same kind of triangle, right? And instead of having angle, angle, side, I'm going to have side, side, angle, side, side, angle, okay? So instead I have that, right? So it is possible that if I have another triangle that has 2 sides and the non-included angle, like this one, then it is possible that they can be congruent, but not necessarily. This angle right here and this side length are not locked down. I don't know what they are. They could possibly be more than one thing if I could draw this differently, and I can. I could take this side length right here and I could swing it in, and it could look like, well, let me see if I can do it a little bit more accurately. Well, we might have to pretend a little bit. It could look like that, and it would be congruent to this side. So instead of having this big triangle right here, I would have this little one. And I still have 2 sides in the non-included angle, congruent to 2 sides in the non-included angle. Clearly, the triangles are not congruent. You with me on that? So there's possibilities. So when we go and find a missing angle, let's say we're finding this missing angle right here. So if I find this angle, well, whatever this angle is, right? But if I swing this in, and that angle doesn't even exist in this little triangle right here, this is still the same as this one, right? Because it's an isosceles triangle. Y'all agree with that? So it could either be this angle or this angle. And how could I figure out what this one is if I know this one? Subtract from 180, because this is what kind of pair? What's it called? Linear pair. It's a linear pair, so they're supplementary. So it could either be this angle or the supplement of that angle. So I've got 2 options, right? And maybe they both work. Like it could be this or it could be this. It is possible, so here, let's read what this says. It says, watch out. When finding angles, it's possible to have 1 solution, 2 solutions, or no solution. So if we were using angle, side, angle, or angle, angle, side, 1 solution every time. If you have side, side, angle, you could have 0, 1, or 2. Okay? And it's called the ambiguous case. Right. So to get through this, here's a few things that we have to think about and know. It says the sine function always has a range between blank and blank. That means if I ask you, what is the sine of this angle, whatever the angle is? What's the biggest number you can give me as an answer? Think about your unit circle. The sine of, like, what's the sine of pi thirds? Square root 3 over 2. Can you give me a number that's bigger than that? 1. What's the sine of pi halves? 1, right? Can you give me anything bigger than 1? No, that's the radius of the circle. It's not going to get any bigger, right? So that's the biggest number you could give me. What's the smallest number you could give me? -1. Because 1 and -1, okay? The range, and look, it says a range between. If you picture the little circle, right? This is your x-axis. This is your y-axis, right? Isn't that where range comes from? This is -1. This is 1. So your range is between -1 and 1. That's important for us to know. So then it says angles with a positive sine function can lie in which quadrants? 1 and 2. Sine is positive in the first and second quadrants. To find the other possible angle, what do? We subtract from what? 180. And then we know that the sum of the angle measures in a triangle is always what? 180. Two different reasons we're using 180 there. So keep that in mind. And no triangle can have two what kind of angles? That is a true statement. Give me another answer. That's not wrong. It's just not what I want in the blank. Obtuse. Good. So you can't have two right angles. That is a true statement, but we're not going to be dealing with right angles here, and so it's the two obtuse angles that we'll worry about. Okay? We all good so far? All right. So here's this triangle that we already drew and labeled on Friday. And so we know that it's side-side angle. Since it's side-side angle, we're going to start the same way we did on the other ones, but there's some other things that we have to look at. All right? So this angle, 60, goes with 27. Theta goes with 30. So it's still the law of sines. The sine of 60 over 27 equals the sine of theta over 30. So then I'm not really cross-multiplying like I did before because I'm trying to get the sine of theta by itself, so I'm just going to multiply both sides by 30. So I'm going to get sine theta equals 30 times the sine of 60 over 27. So that means that theta is equal to the sine inverse of 30 times the sine of 60 over 27. So go ahead and type that in. Make sure your calculator's in the correct mode and everything. I get 74.207. Do you agree with that? That's one possibility. Then, once you have that angle in your calculator, you could store it if you want to, but you don't really have to. You can just do 180 minus answer, and it'll subtract the last thing so that you can get the other possibility, which would be what? You subtract this from 180. 180 minus your answer. What do you get? About 105.793. Okay. So those are our two possibilities. Maybe they both work. Maybe they both don't. Maybe just one of them does. I have to check it. Okay, just because you got answers doesn't mean they're going to work. Because once I take this angle and I put it in here for theta, there's three angles in this triangle, right? So when I add 60 to this angle, I still have to have room for a third angle that I don't know what it is. You with me on that? So that means when I add these two together, it has to be less than 180. Can't be equal to 180, can't be greater than 180, or there's not room for that angle. You with me? Because angle C could be this angle, or it could be this angle. We don't know what's going on with this side because it's side-side angle, so it could swing either way. It's not three-dimensional. This green side could be here, or it could be here, and that's what the triangle looks like, but we don't know what the triangle looks like. There's options because of the information that you have. It could be here, and you ignore the green one, and it's the big purple one. Yeah, we don't know what it looks like. Because of the numbers that we have, we don't really know how to draw the triangle. Just because I drew it and it looks like there could only be one possibility, that's just because it's a bad drawing. Okay. Okay. No. Yes. Do you see the big purple triangle? Okay. Then this triangle right here, that's the other possibility. It still has these two sides in this angle are congruent to these two sides in this angle. But you don't know how to draw it. You don't know if this angle right here is obtuse or if it's acute. It could be either one because we don't have that third angle. Yeah. Exactly. All right, let it marinate for a little more. Get it. Okay. So even though just because you got two answers doesn't mean that there is two answers. Okay, so we have to check them. That means we take this 60 that they gave us, and we're going to add it to this 74 point whatever. The actual number doesn't matter. All you care about is that when you add those together, is it going to be greater than or less than 180? Less than. This is less than 180, so it works. Then I take 60 plus 105 something. When I add it together, is that greater than or less than 180? Less than 180. So then they both work. It could be either one. I could build two different triangles. Okay? I could build an acute triangle. I could build an obtuse triangle. Okay. Right. There's two different triangles we could build. You could, on some things, depending on the information I give you, you can only build one triangle and that's it. On the front, you can only build one triangle. With this information, you could have built two. Okay. Yes. Okay. All right, so let's do number 7. So we're going to draw and label the triangle. This is 89 degrees. AC is 34. AB is 26. All right, so this again is two sides in the non-included angle, so it's side-side angle, which means I use the law of sines, but I have to check for other stuff, right? So I'm going to take the sine, 89 goes with 26, so the sine of 89 over 26 equals the sine of theta over 34. Which means that the sine of theta is equal to 34 times the sine of 89 over 26. Well, sort of, but that has nothing. It's not that they switch places. Is that B could be big like this, or it could swing in like this. Like, I don't know what size it is.
But theoretically, like B and A, their values, because we don't know them.
Oh, well, yeah. They could be anything. They could, yeah. Yes. Sort of. Okay, that, yes. Okay, so what happens when we're getting this one? Are you getting errors? Yes. Okay. So sometimes we get errors just because we type things in wrong, right? Sometimes we get errors because we're not really going to get an answer. So now what I want you to do is just type in this fraction part. Okay? So theta is, yeah, the 34 times the sine of 89. Just what's in here, not the sine inverse part. We're going to write that down. But it depends. That's a tricky question. Could be just the angle, but it might not be. We'll get there. Don't worry. So don't you get 1.3074 something, something, something? Okay, so why are we getting an error message? Because it's bigger than 1. If sine can't be bigger than 1, can't be less than -1, so you can't take the sine inverse of something that's greater than 1. Okay, does that make sense to you? So here's some things to think about. Yes, sometimes we get errors because we hit the wrong thing on the calculator. It happens to all of us, right? So if you don't want to get an error and then wonder if maybe it was for this reason, maybe I just messed up, you could on all of these, even here, you could type this in, get a fraction, get a decimal, make sure it's between -1 and 1, and then you could just do the sine inverse of the answer, and then you'd be fine. That way, if you get something that you know doesn't jive, then you don't have to worry about doing anything else. Your answer here is no solution. The information that you have is not going to create a triangle. Never. Ever, ever. Yeah. Okay? How are we doing? We good? Okay. Let's do number 8. How are we doing, Michael? All right, so draw my triangle. Make this angle C. AB is 24. I'm looking for angle B, 21. So I've got two sides in the non-included angle. It's side-side angle. So I've got the sine of 102 over 24 equals the sine of theta over 21. So sine theta is equal to 21 times the sine of 102 over 24. So you could try on this one to type in just the fraction part, make sure that decimal is somewhere between -1 and 1, and then just do the sign inverse of the answer. You don't have to store anything, and then get your answer. So what do we get for the first theta? Okay, good. Do we all agree with that? And then what do we do to get the other one? Subtract from 180, yes. Yes, 121.143 degrees. Okay, so those are my two possibilities, right? Now I have to check them. So I have to take this 102 plus 58 something. Is that greater than or less than 180? Less than 180, so this one works. Then I take 102 plus 121, and that is greater than 180. Oops, greater than 180, so that's a no. So this one doesn't work. It's just one answer there. Why do you think that is on this one? Because you can't have two obtuse angles, exactly. Because if you start with an obtuse angle, you're not going to get two answers, because the two answers you have, one will be acute and one will be obtuse. So there's all these rules that you can remember, but I don't know that it's necessary. If you just do it the same way every time, find the two of them and check them, you don't have to worry about all the little rules and stipulations, because that can get a little hairy in your mind, I think. All right, so y'all do number 9 on your own. When you're done, check up here with me, see if we agree. And remember, when you're checking them, the actual value doesn't matter. If you can look at it, you should kind of know if it's going to be greater than or equal to, or greater than or less than 180, and you'll be fine. Okay. What questions do we have? Are we all good? Yes? All right, then y'all do number 10. I think if you just arrow.
I like typing number on that.
Yeah, that sucks.
37 something.
I don't know. I don't think you can go back after that. Okay. Okay, yeah, that's good. That's another reason why sometimes it's good to store things even when you don't need to, because, yeah, I've been there, definitely. No, it's right. It's right. I was trying to draw the picture. I was trying to draw a picture so I could show him the two, but that's not like a 30-degree angle. That's why my picture looks bad. The answers are right, but I was trying to. No, it should have been like. This is the obtuse angle. Yeah, that's the problem. Yeah. So like this would be my 30. This would be that 31 that I found, and this would be the 28 and the 29, right? And then, well, not in this, but in this triangle it can. It's what this can be two different things. Or it could look like this. This would be the 148, this would be the 30, and this would still be 28 and 29. Like it could work either way. Mm-hmm. So my pictures are not to scale by any means, but you can build two different ones. Where the information on the front, you can't build two different ones. What it is what it is, and it's not going to flex to change anything else at all.
So as long as it makes sense.
Yes, yes, yes. Yes, okay. All right, look at number 11. Let's go ahead and, y'all go ahead and start number 11. Then I think you're going to have some questions. So. See, I knew you were going to have some questions. Okay, so this is still side-side angle, all right? And then 125 goes with 21, so we'll be able to do the sine of 125 over 21. The problem is theta is across from AB, and 24 is across from A, and nobody asked me for A, right? So I need to find something that they didn't ask me for. It's going to be easier for me to find the, well, the only really option I have is to find the missing angle, cannot do Pythagorean theorem because it's not a right triangle, okay? But do I have enough information to find this angle? And then if I have this angle, can I then find theta? Yes. Okay, so I'm going to call this angle alpha. Looks like a fat Jesus fish. Okay? So this is equal to the sine of alpha over 24. So now I just work it, completely finish alpha, then I worry about what theta is. Okay? So that means I'm going to get the sine of alpha is equal to 24 times the sine of 125 over 21. Alpha is equal to sine inverse of 24 times the sine of 125 over 21. Yes. Yeah, so in this case, when you find these two angles for alpha, I would store them both. Because we need to store them both, we need to finish them, and then you need to use that exact number to find theta. So having it stored is not a bad idea so that you don't have to go back and... But still before I worry about theta, all I should be worrying about for theta right now is that I need to store those so I can find them later. I have to completely finish alpha. I've come up with two possibilities for alpha. What should I do with them now? Check them, yes. Find to see if maybe they both work. Because if they both work, because see, if I change this one from 31 to 148, it changes the other one too. So they both change. Well, this one's not going to work because it's obtuse. So you're right. So that 125 plus 110, that's definitely going to be greater than 180 because it's obtuse. So that one definitely doesn't work. 125, 69 is not obtuse, but 125 plus that 69 whatever, that's also greater than 180, right? So then neither one of them work. And your answer again, I shouldn't have boxed that. Let me unbox that. So your answer then is no solution. Yeah, so now you don't even have to worry about theta. But let's talk about a couple of things. You could get no solution more than one way. You could get no solution because you're trying to take the sine inverse of something bigger than 1 or less than -1 like we did on the other one. Or maybe you actually get angles. Whether it's an alpha theta thing or an alpha theta thing or not. This didn't happen just because it was a theta question. Okay? Just so happened to work that way. Now, listen. Y'all are shuffling, you're not listening. Let's say that alpha worked. Let's just pretend. Both of them worked. We have two answers for alpha. Then we have to go find theta, and we're going to have two answers for theta, right? So all you would do then is take whatever worked, add it to 125, subtract from 180, and boom, there's your answer. Does that make sense to you? So just make sure that you might have one where you actually need to finish it. Okay. What questions you got? Anything? If one of them didn't, instead of both of them, then you would just have one answer. Yeah. So just like for theta, for alpha, I could have 0, 1, or 2 answers. And however many answers I have, that's how many I have for the other one too. That's a good question. What else? Anything else? Yes. All right. You have your assignment, so work on that.